everyone. So for today's video, we have laboratory activity number 2, which is circuitry. So the objectives for our laboratory activity number 2, so we have first to determine the relationship between current and voltage and the relationship between current and the resistance. The second one is to determine the total resistance of resistors and the voltage across each resistor connected in series and parallel, and to determine the total resistance of resistors and the current flowing through each resistor connected in parallel. So to have a short background concepts, let us recall of what concepts or lessons that we discussed during your junior high school about current, voltage, and resistances. So an electric circuit that we're going to look into today, based on the picture that we have, this one. It is a conducting loop which current can transfer electrical energy from a source to a load. So when we say a source, it is where the voltage will come in. And when we say the load, it is the one that will consume the energy coming from the power source or the load source. And this electric circuit is consist of the following. We have the source, which provides the voltage needed to force current through the circuit. So an example of a power source is this dry cell. Then we have conductors, which are the electric current can travel through. So an example of a conductor is a copper wire. Then a load is a device that converts electrical energy into some other useful form, such as light bulb or resistors. And then we have a switch, which continues or discontinues the flow of electric current. So the switch, if it's open, so no electric current that will pass through. So if the switch is closed, then it will free flowing the electric current on this said circuit. Circuits have two types. So we have series circuit, which has two or more loads, but current flows through a single conducting path. So the conventional flow of electric current from positive to the negative moves on this path. So we have here the red path moving to the black, which is the negative, and back to the red, then back to the negative side, which is the black. Then we have the red one, then go back to the black side for the negative terminal. So you will notice that the arrangements of the loads are in this kind of pathway, so that there is only one path taken by the electric current as it moves from the positive to the negative terminal of the power source. So these are the types of our one of our types of our electric circuit. Then we have the parallel circuit, as has more than one path for electric current to flow. So we have here a path moving from the positive to the negative. So we can have path number 1. So it may take load number 1, then go back to the negative terminal, or it will go to load number 2, then go back to the negative terminal, load number 3, and then go back to the negative terminal. Let's take note that this is a direct current, so the only flow that will only happen is that it will pass through the positive side of the load and moves out of the negative side of the load, going back to the negative terminal. So it will not be possible that it will move from the positive, negative, then the negative to the positive, and so on. So it will only be moving from the positive to the negative. So load number 1, then load number 2, then load number 3. So the moment that this is turned on, so if there is a switch here, all light bulbs will light up. So if I remove the load number 1 or the first light bulb, the 2 other light bulbs will still be lighted on. While if we have on a series circuit, if I am going to turn down or remove one of the light bulbs, you will notice that it will come up with an open circuit where there is no electric current that will flow to loads number 2 and number 3. So you will notice that it is just a single conducting path. So moving on to our concepts, background concepts, let's look into the rules followed in series circuit. So the rule number 1, the current that flows through each resistance is the same as the total current throughout the circuit. That is, the total current is equal to I1, which is equal to I2, which is equal to I3, and so on. So here, the total current that is flowing on the entire circuit is just equal to each other loads. The next rule is that the sum of the individual voltage drops is the same as the applied voltage. So the total voltage is only the sum of the total voltage drop on each load of our circuit. So that is the total V is equal to V1 plus V2 plus V3 plus V sub n, or and so on. Then rule number 3, the total resistance is equal to the sum of the individual resistances. So the value of the resistance 1, resistance 2, and resistance 3, we're just going to get the sum of it to identify or to get our total resistances. For the rules followed in a parallel circuit, so we have here that the total current that flows through the circuit is equal to the sum of the currents in the separate resistances. So in this case, the current is the total amount of current that is flowing in our circuit is equal to the individual current passing through each load. So we will add all the individual currents that is passing through our individual loads to identify the total current that is flowing within the circuit. In number 2, the voltage in each resistor is the same as the magnitude of the applied voltage. So whatever the source of or whatever voltage reading on our source is the same voltage reading for each loads that we have. And then number 3, the reciprocal of the total resistance is equal to the sum of the reciprocals of the individual resistances. So we have here that is 1 over RT, the total resistance, is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus so on. So getting that, identify the total resistances, we will get the reciprocal. Okay. So for our activity, we are going to use the FET interactive simulations entitled DC Circuit Construction Kit, which I have the link on this PowerPoint presentation. So for our procedure, let us look it into step by step or one by one. For procedure A1, we need to have this to follow. Number 1, we connect one 1.5 volt dry cell, a light bulb, a switch, and an ammeter in series. Then we connect the voltmeter across the dry cell. Record the voltage reading from the voltmeter and the current reading from the ammeter using the data table. So we have here, if we have one dry cell, we will get the voltage reading here. And then what will be the resistance? We have it, the value later. And we are going to look into the amount of current reading by the ammeter. Then we will repeat step 1 using a different number of dry cells in each trial. In this case, we are going to use 2 dry cells for the second trial and 3 dry cells now for the third trial. Then we are going to plot the voltage against current to determine the relationship from the graph using a Microsoft Excel. So you, the students, will do it later. The next procedure for A2, we're going to, number 1, we're going to connect 3. We're going to connect 3 1.5 volts dry cells in series with 1 bulb, a switch, and an ammeter. Then we will record the current reading from the ammeter using the data table. So again, we are going to use this one. Then we will repeat steps 1 and 2 using the different number of bulbs in each trial. So we have here on the first trial 1 bulb, and the second trial 2 bulbs, and the third trial 3 bulbs. Let's take note that we are going to connect the bulbs in series circuit. Then we will again plot the resistance against current and determine the relationship from the graph that we're going to have using Microsoft Excel. For procedure letter B, so we make a series circuit consisting of 3 resistors attached to a 6-volt power source and a switch. Then we connect the ammeter in series with the resistors. Then we close the circuit and record the reading in the ammeter using data table B. Then use the voltmeter connected in parallel to the resistor to determine the voltage drop across each of the 3 resistors. So here, we're going to determine the current flowing in resistor 1, 2, and 3 and identify the total current that is passing through the circuit using the rules presented a while ago. Then again, in voltage, using the voltmeter reading, we're going to identify the voltage drop for each resistors and identify the total voltage. And here, we're going to write the value of the resistors and identify or calculate the total resistance. So for procedure B2, we are going to make a series circuit of 3. So we have for B2, so we have to make a parallel circuit consisting of 3 resistors attached to a 6-volt power source and a switch. Then we connect the ammeter in series with each resistors to identify the current flowing on each resistor and close the circuit, the switch, and record the reading in the ammeter using data table number 2. Then we use the voltmeter connected across each resistor to determine the voltage in each of these 3 resistors. So we are going to look into the values of this as we connect them in a parallel circuit. So the B1 is in series circuit. So we now move on to our PET interactive simulations. So we are able to do our activity. So let's get familiarized with our circuit construction kit for DC Virtual Lab. So we have here our wire, battery, light bulb, resistor, switch, and so on. So we can use a pictograph or a picture representation, or a schematic diagram. So in this case, we are going to use the picture diagram instead of the schematic diagram. So before that, I will show you how we are able to draw the schematics of this. So we have the wire as a long line, and we have a fuse, a line with a box. So a battery. So dry cell, technically we have one small and one bigger. If it's battery, it should have two of this to become a battery. Then we have a light bulb resistor. That's how we draw it. So you will notice a resistor schematic diagram is similar with a dollar bill, paper clip, coin, eraser, because this gives us resistances. Okay, so we're going to use this photo diagram for this example. So we are going to have first to come up with our series circuit. So the first one is to connect 1.5 volt dry cell, a light bulb, a switch, and an ammeter in series. So we start with a wire. Then I have here my battery or my dry cell. So we have here to click the element to edit. So I have here how many voltage do I need is 1.5 volts only. For that 1.5 volts, okay, and it is connected with a switch, and it will be connected again to a wire, and then it will connected to a light bulb. Okay, then we will have our ammeter here. We can move this here and place some wire. So we connect our ammeter. That's it. So we will just close our circuit with another wire. So you will notice there is already a value here. So there is no reading at the moment because the circuit is still open. So that. Then we will connect a voltmeter across the dry cell. So we're going to put it here. Let's take note that this is the positive side. So we will place the red one here. I think it's not properly. This one and this one. So we will place the red one here. The positive. So positive here, then moving to the negative. So please take note. Okay, so that's how we are going to read it. So we have one dry cell connected to a light bulb switch and an ammeter in series. Then the voltmeter is connected in parallel or across so that we can able to see the voltage drop. So then I switch it on. So there is now a reading, current reading, and there is now a voltage reading on the voltmeter, the current reading in the ammeter. Let's take note that we are currently looking at an electron flow. So we click the conventional flow. So it's from the positive to the negative terminal. Okay. So that is for one dry cell. So since we have the current reading and the voltage reading, we can identify what will be the resistance of our bulb by calculating it through the use of Ohm's law. So now we will cut. Let's open again. We'll cut this and we will place another dry cell. So I have now two dry cells. placed. So 2 dry cells, dry cell, to 1.5 dry cells. So turn it on again. So we have now trial 2. We have a current reading here and a voltage reading. This is the voltage that is passing through. So let's open again and cut. We'll add another dry cell and then turn on. We have now another current reading and a voltage reading. Oh, turn this into 1.5. Okay, that's 1.5 volts power source in the switch, the light bulb connected in series, and the current that is flowing. So we are able to place the voltmeter across. Okay. So let's proceed to the next step, the next procedure. So in this procedure, we are going to connect 3 dry cells, and now we are going to have to identify again the voltage, the resistance, and the current. So in this case, we are going to place the number of bulbs. So we will have 1 bulb, 2 bulbs, and 3 bulbs for each trial. So let's turn on this one. So we'll remove the voltmeter here. Cut. Okay. So we'll place 1 bulb first. Then we will identify the voltage. Then what will be the total resistance for 1 bulb and the current that is flowing. So again, we place the positive here. Place the negative on the other side. So turn it on. That's our reading. We will have now a constant value for the voltage, for the value of our battery. Then let's cut this and place another light bulb. 2 light bulbs. Connect now. Okay. Let's see what happened to our reading. So we will place the positive here. Sorry, we will place the positive here. Place the negative here. You notice that if we are going to place the negative probe here, there will be a misreading. We are going to look into how much voltage is passing through the 2 bulbs. Okay, so let's open again. Let's have now another light bulb. Okay, so we have 3 light bulbs now, and we will connect the negative here and the positive here. Then turn on. So what's now the relationship that we are going to see? Okay. Let's move on to the next procedure. So in this procedure now, we're going to connect in series 3 resistors to a 6-volt power source. So I can have one power source here with 6 volts. So I have here 6 volts. So check how much voltage do this have. So it's 6 volts. Okay. Now, then we will place some wires and a resistor. So I have resistor 1, resistor 2, and resistor 3. Then we will come up with an ammeter connected in series with the resistors. So I need to cut this. So we will place an ammeter here. Another ammeter. So once the electric current passes through the resistor number 1, it will record the current passing through resistor 1. Then as the current passes through resistor 2, this ammeter will record the current that will pass through the current pass through the resistor number 2. Then we will have another current. So we have another resistor. Then we will have another ammeter. In this case, we don't have a switch, so we will place a switch before the resistor. Here, connect the wires. Okay, and then we will use the voltmeter. It's connected in parallel to the resistor. To each resistor to determine, we will check the voltage drop to each resistor to determine the voltage reading for R1 for this resistor 1, resistor 2, and resistor 3. Let's take note. The reading here will be I1, the reading here will be I2, and the reading here will be I3. Then when we place the voltmeter here, this will be negative, this will be positive. So that will be voltage 1, another 1, it's voltage 2. Okay. So I can only have 2 voltmeters here. So later on, I will put it on this side. Okay, so let's start. So once I click, so there is now a voltage reading here in our voltmeter. So the voltage drop here is this one for V1 for the resistor 1. We have a voltage reading here at resistor 2. So I'm going to transfer this to our next resistor to identify what is the voltage at resistor number 3. So there is now a current passing through and the voltage here. So this is a resistors. These are resistors. So we have here the reading for voltage. So you're going to place this on table B1. The current reading, then identify the total current. The voltmeter reading from the voltmeters here. So this is resistor 3. So again, let's place the voltmeter to resistor 2. Then we have resistor 1 as V1. Then what will be the value of our resistors? So each resistors have 10 ohms. I place 10 ohm resistors. You will notice that if I'm going to change later, I will show you when I change the value of the value of the resistors that I have, it will change the bonds here. So we have 10, 10, and 10. Okay. So we have here 10, 10, and 10 as the value of our resistors. This is resistor 1, this is resistor 2, this is resistor 3. Okay. Let's move on now to B2, our last procedure. Okay, for this procedure, we are going to reset first. So again, we will have 6 volts power source. So 6 volts. Again, we will have a wire. And in this case, our resistors will be connected in parallel circuit. So I just place some wires so that when we connect, it's very easy for us to see the values of our resistors. Okay, so we need to have a switch. Let's cut this one. So may burning. So okay, for procedure B, so we make a parallel circuit consisting of 3 resistors. So we have here 10 ohm resistors. Let's check the value. So I have here 10 ohms for resistance, resistor 1, resistor 2, 10 ohms, resistor 3, 10 ohms. So here we have a 6 volts battery, and it's connected now. Our ammeter is connected in series with our resistors. So we're going to check now the voltage will drop for each resistors. So again, this is the negative and this is the positive. So we have here a voltage reading here. So we place it here and here. So we have another voltage reading. Place it this one, and another voltage reading. So again, this is on a conventional flow. I mentioned earlier that when we place a resistor and change the value, you will notice that the bands of colors here changes as well. So if I have, so you notice I have the black one turned into brown because it indicates the amount. So you notice it's red, white, black, and the gold, which is the tolerance level of our resistor. Then we have the first digit and the multiplier. First digit, second digit, and a multiplier. So when we move it up, it changes the voltage. Okay, so let's move on now to the next part of our presentation, our video. We now move on to the guide questions for you to answer. So the first guide question is that what happens to the brightness of the bulb as you change the number of batteries? Will it bright greater or lesser? So the brightness becomes lesser or greater. Then number 2, what does the brightness of the bulbs indicates? Number 3, how does the voltage drop across each resistor connected in series related to the total voltage? And number 4, how is the current passing through each resistor connected in parallel related to the total current? So for our application, you need to answer the following questions. So using the knowledge that we have gained in our activity, you need to draw in a schematic diagram or a circuit diagram 3 resistors with 12, 8, and 4 connected in series to a 24-volt battery. You need to draw a circuit diagram. You include a switch, a voltmeter, and an ammeter. Then you find the total resistance, the total current, and the total voltage for each resistor. Then for number 2, again, 3 resistors 12, 8, and 4 are connected respectively in parallel connection to a 24-volt battery. Again, you need to find the total resistance, total current, and the total voltage across the voltage across each resistor. So with that, thank you very much for viewing this video of laboratory activity number 2, the circuitry. Thank you very much.